Yes, I want to go over a homework problem from section 4.2. This is Math 1430, and I am Dave, and here we go. So here's the question. Find the relative extrema, that means relative maximum or relative minimum, and then we want to classify the extremum as either a relative max or a relative min. And we're going to do that by the second derivative test, which we're going to see how that works. Okay, so here's the function they give us. F of t is equal to 2t plus 1 over t. It's always nice to know what the domain of your functions are. So this original function, obviously you cannot divide by 0. This t can be anything, but here we cannot divide by 0. So the domain of f is the set of all t such that t does not equal 0. That means everything else is in the domain. So the domain is all real numbers except 0. Okay, so to find critical numbers, we want to find the first derivative. So before I find the first derivative, I'm going to rewrite f. Rewrite this function so it's more derivative friendly. So here we go. F of t is equal to 2t plus t to the negative 1. So that's key. Instead of writing 1 over t, isn't this more derivative friendly? I can just use the power rule for this derivative instead of the quotient rule. You'll get the same derivative, but this is much quicker. Now that I have my function in derivative friendly form, let's take the derivative. Make sure you notate f prime of t. So the derivative of the first term is 2, and then by the power rule we get minus t to the negative 2 power, because you decrease the power by 1. We brought down this minus 1 to get that minus there. And then it's always nice to get your derivative without negative exponents. So this is the same thing as saying 2 minus 1 over t to the positive 2. So this turns into that. And what's the domain of this derivative? Again, it's going to be everything except 0, because you can never divide by 0. Okay, since I want us to use the second derivative test, that means we have to find a second derivative. So why not do the second derivative now? So to find the second derivative, f double prime of t, take the derivative of this form. It's easy, this is derivative friendly as opposed to this form. So the derivative of the derivative is going to be, let's see, wow, this should be a 0, right? Yeah, so the derivative of a constant 2 is 0. So let's get rid of that. I was just kidding. So this is just going to be, the derivative of this second term is going to be 2t to the negative 3. And that's going to be the same thing as 2 over t cubed. And what's the derivative of, what was the domain of this second derivative? Again, everything but 0. So the domain of f double prime is that. Okay. So now that we have all these derivatives, we want to find these relative extrema. So here's an important point. Relative extrema, they occur or live at critical points. So that's key. We must find the critical points because if we do have relative extrema, they always occur at the critical points. So that begs the question, how do we find critical points? There's two ways. Number one, you set your first derivative, f prime of t, equal to 0. That will yield critical numbers. And also, see where it's undefined. So that's the two ways to find critical numbers. Set the first derivative equal to 0, and where is f prime undefined? Okay, so here's my derivative, and I think it's easier to look at this form, the simplified form. So when you see the simplified form of the first derivative, it's very obvious that we're undefined when t is 0, because you can't divide by 0. So we are undefined at t equals 0. But this is not a critical number. Why? Because I just said when you set your first derivative equal to 0, I'm sorry, I just said when you see where your first derivative is undefined, that's going to be one way to get critical numbers. So it is undefined at t equals 0. But why is this not a critical number? Why? Why? And the answer is t equals 0 is not in the domain of f, the original function. To be a critical number, you have to be on the graph of f. You can't be on the graph of f when t equals 0 because t equals 0 is not in the domain. So let's reject t equals 0. This is not a critical number. It's not a critical number. So the other way to get critical numbers is to set your first derivative equal to 0, which we did here. And then let's add 1 over t squared to each side. You know, when you're computing to find t in an equation, you don't want negative exponents. So that's why I wrote 0 equals this simplified first derivative. Okay, that was my twin brother sneezing. So the next step, this implies that 1 over t squared is equal to 2. Now we want to clear the fractions. So I multiplied both sides by t squared. When I multiply the left-hand side by t squared, the t squares cancel, and so I'm left with 1 equals 2t squared. So I want to solve for t. So divide each side by 2 to get 1/2 equals t squared. And then take the square root of each side. So when you do a square root of each side, don't forget that plus or minus. So I'm going to get t equals plus or minus the square root of 1/2. And by property of radicals, that's the same thing as plus or minus the square root of 1 over square root of 2. So the square root of a fraction is the same thing as the fraction of the square roots. Next, let's rationalize the denominator. We don't want square roots in the denominator. So I multiplied by another name for 1, square root of 2 over square root of 2. So my simplified values of t are plus or minus square root of 2 over 2. Because what's the square root of 1 times the square root of 2? It's the square root of 2. What's the square root of 2 times the square root of 2? Just 2.
And let me interject for a moment. So notice when t equals these two values, we get 0 for f prime. And what does that mean? If f prime is 0, doesn't f prime mean the slope? So what does it mean if the slope is 0? It means you have a horizontal tangent line. So if I just make up some graph like this, isn't this a horizontal tangent line? And so is this one. Notice the horizontal tangent lines where f prime equals 0, they occur on the
Max, relative max, or
Yeah.
relative min.
what do you call this, like a mountain and a valley? So yeah,
peaks and
so they
valleys.
occur at the maximum and the minimum. So that's why it's so important to set the first derivative equal to 0. That's how you find the critical numbers. For what value of x on f will the peaks and valleys occur?
And also, where the first derivative is undefined, the derivative is undefined at a sharp point or a cusp. And notice this, for this little graph I just drew, isn't this a relative max as well? So maxes and mins are found by setting the derivative equal to 0 to get those horizontal tangent lines, because don't horizontal lines have slope 0? Okay, so let's continue along. So we have two critical numbers, the positive square root of 2 over 2 and negative square root of 2 over 2. And these are in the domain of f, so we can accept these as critical numbers. And now here's what the second derivative test tells us to do. You want to input these critical numbers into the second derivative, so we can apply the second derivative test. So going to our second derivative, and I'm going to choose the simplified form because I don't want to compute with negative exponents. So f double prime of the square root of 2 over 2 is equal to, let me get rid of this 2 because that was not in the derivative. So the second derivative is just this, because remember, the derivative of a constant was 0. This is 0. Minus is 0. Yeah, minus. Okay, so I set 0, let's see where I am here. Okay, here we are. So f double prime of the first critical number is going to be this. Because again, f double prime, we have right here, 2 over t cubed. So t is the square root of 2 over 2. So 2 over t cubed. Isn't a positive divided by a positive a positive? I don't even care what the actual value is. I just want to know the sign. So whenever your second derivative is positive, that means for that interval, the graph is concave up. Whenever you have concave up, you go through a minimum. So here's what the second derivative test tells us. If you go f double prime of a critical number and get a positive result, that automatically means you're going to have a relative minimum at that critical number. So we have a relative minimum at t equals square root of 2 over 2. And finally, when I input negative square root of 2 over 2, my other critical number, into this second derivative, I'm going to get a positive over a negative because a negative cubed is negative. So whenever your second derivative is negative, I like to think of that being concave down. So second derivative negative means on that interval the graph is concave down, which means you go through a relative max. So the second derivative test tells us when you go f double prime of a critical number and get a negative result, then you have a relative maximum at that critical number. So here are my final two answers.
By the way, this would be positive. I understand what you did here, but
Oh yeah, f prime was, let's see, how is that?
if you take the derivative of this,
Oh yeah,
f prime of t,
yeah, we get a positive 2t to the negative 3. Yeah, this is a positive and a positive. So in any case, yeah, so we did it right other than that. Okay, so this was our second derivative. 0 plus this is just that. And that's what we have, 2 over t cubed, 2 over t cubed. Okay, I think that covers it. Good night, everyone.